So you're going to learn about R, the programming language that is the most commonly used for data analysis. And specifically, what you'll do is you'll create an RStudio.cloud account. And with that account, you'll analyze data with the command line R. What that means is you'll be typing commands in, not selecting them from a menu. You'll choose a built-in data set that comes with R, and you'll generate summary statistics like mean and minimum. You'll load an external library of commands to give graphics commands to R, and with those graphics commands, you'll plot the relationship of two variables. From that plot, you'll generate what's called a regression line or curve. And with that regression line, you'll use one of the core techniques of machine learning to predict an unknown value from that plot. Finally, you'll assign a new database to a variable. RStudio is the easiest way to get rolling with R. So just open up a browser and type in RStudio.cloud. When you see this screen, click the Get Started button, and you'll see the screen to enter your email, create a password. The first name and last name may be accurate or they may be fictitious to protect student privacy. When the account is created, you'll see this New Projects window. Just click New Project. The deploying project may show for a little while until the project is created. Here's the main window of RStudio. RStudio is an integrated development environment, or IDE. This area to the left is where you type. The windows to the right we don't have to worry about. You won't be using any of the menu items. Let's look at where the flashing cursor is, and you can follow my lead to see how we access this. We're going to access a built-in database or data frame from Motor Trend magazine on cars. Head will show us the first 6 lines so we see what it is. And in parentheses, mtcars, all lowercase, no spaces, press enter. And here we have some car names on the left, and across the top, the names of the variables that are recorded. Looking at that, you can notice something. Here is the highest mileage vehicle, almost 23 miles per gallon. And if we look at the weight of that vehicle, okay, it's 2.3 tons. If we look at the lowest mileage, about 18 miles a gallon, you might guess, gee, is that heavier? And in this case, yes, it is. Well, we may want to explore that possible relationship later, but let's look more at what's in this data set. We can do that by looking at the database structure, just the str command, and again, mtcars. It shows us the definition of its data frame. It contains 32 observations, meaning 32 models of cars, and we already saw the 11 variables. And it tells us that, each one is a numeric variable, and it has some examples of them. Okay, let's look more closely at these variables. So let's get a summary of the statistics here. The word summary, and again, it's a summary of mtcars. Here we have a summary of each variable. We had looked at miles per gallon. If we look at the worst mileage of all 32 cars, here's a vehicle that only gets about 10 miles to the gallon. The best mileage is about 34 miles per gallon. And then we have a mean or average here. If we look at weight, sure enough, there's a variation of the lightest weight vehicle is 1.5 tons, and the heaviest is about 4.5. Wow. Well, it's hard to get a picture of this stuff just by looking at numbers, isn't it? Let's look at graph. R allows us to add capabilities to the programming language by adding what are called packages or libraries. So we're going to do that now. Typing in install packages. As you type, you see some choices coming up. And you can click on the one that you want. install, not installed with an ED, but just install packages, quotation marks, the package we'll get is ggplot, P-L-O-T, 2. That package, that command, will go out to the internet and find the ggplot2 library of graphics commands. And this takes a few moments because it's going out to the internet and looking. The text in red is just informative stuff to let you know what RStudio is telling you. In this case, it's telling you what it's found and what it's installing. These are all very small files. Error messages will also show up in red. Now everything has been downloaded, we have our blinking cursor, and we can continue. We've installed the package. To activate that particular library of commands, we just type in the word library and then ggplot2, just like that. Again, no capital letters, no spaces. When you press return, nothing happens because it just has activated that library. If there was an error, it would tell you so in red text. Well, now let's plot something. So the command to do that is just ggplot, not 2, just plain ggplot. The database from which it's coming, which is mtcars, comma. AES stands for aesthetics, meaning what do we want to show within the plot. In another parentheses, we'll define our x and y values. X equals WT for weight, a comma. Y equals MPG. So now, what do we want to display this? Get your cursor out of those parentheses. A space, a plus sign, another space. The geometry we want to display are points. So GEOM _ point. An empty parentheses. No space in there, nothing. Okay? So look carefully at what you have typed, make sure it's exactly like this. When you press return, we get a plot. There's a dot for each car. If you look closely, you'll see, oh, in the top left, there are 3 cars, and wow, they get 30 to 35 miles per gallon, and they're between 1.5 and 2 tons. Wow, okay. What about these 3 way over here in the bottom? So they only get 10 to 15 miles per gallon, and they're between 5 and 5.5 tons. Okay, so it looks like there is some sort of relationship, but we have some empty space here. We're not sure of it all. Let's look at a more intelligent plot. We want to add something to our command rather than type it all, or as a shortcut. The up navigation arrow will repeat what you just typed. What we'll add is a smoothed line, a space plus space and GEOM _ smooth and more empty parentheses. Now when you press enter, you'll see we now have a roughly average line going through all of the points. That's called a regression line. And that line can plot some of the non-existent points. Let's imagine that we wanted to buy a 4.5-ton pickup truck, but we wanted to estimate what mileage should we expect. Here's the 4.5-ton line. And if we go up and intersect our regression line, we can go over and say, oh, the average truck like that should have about a 14 mile per gallon mileage. But it may be as high as maybe 17 or as low as 10 mile per gallon. We may want a straight regression line. Let's see how to do that. So again, the up arrow to retype what we just had, backspace into the parentheses, and we'll use a method equals lowercase lm. That's not a 1 and an m. Check to see that you have everything typed exactly the same. Now we have the best straight line that connects those points. It's not as accurate as the curved line, but it's a little easier for an Algebra 1 student to understand and a little simpler for plotting. Let's review these commands with a different database. So we've looked at cars. Let's look at crime. Let's type in the word crime as a name of the database that we'll use. Now, there isn't one named crime, but that's what we want to deal with. I've entered a less than sign and a dash, okay? It looks like a little arrow. The specific database we'll use is USAssaults. Notice this starts with 3 capital letters. The rest have to be lowercase. It's a little bit long to type. This command says that, okay, we're going to take the name USArrests and we're going to assign that to the word crime. Instead of typing USA arrests and getting the capitalization all wrong, we just have the word crime. Let's do the head command again. And we just have to type crime to see what does this database look like. And we see, there are states down the left-hand column, and there are 4 categories related to U.S. arrest. Well, let's look at the structure of this database. STR, crime. We see, okay, the data frame or data set has 50 observations. Well, that makes sense, 50 states, right? 4 variables. Murder is a numeric variable. Assault is an integer variable, so there wouldn't be any decimal points there, and so on. Time to graph. We've already installed the graphics package. We've told R we're using the ggplot library, so we don't have to do that again. So let's just type in ggplot, parentheses, crime, comma, AES, the aesthetics of what we want to put in here. And for X value, let's try urban pop. Now, urban pop is the percentage of population of the state living in cities. Okay, it may not be exactly that, but that's close enough. It tells us how much of the state is composed of city dwellers, comma, Y equals murder. Let's see if there's a relationship between murders and the cities. Again, a plus outside of the parentheses. Let's again use the points, geom underscore point, empty parentheses. Get out of the parentheses, and let's go right to the geom smooth, just like you did above. Check to make sure that everything is typed exactly right. If you make a mistake, you can just use the up arrow and fix that easily. But here's our regression line, and wow, it's kind of horizontal, and the dots seem to be all over the place. A perfectly horizontal or vertical regression line would tell us that there's not a strong relationship between how much of the state's population is in urban areas compared with how many murders per 100,000 residents. Let's see if the crime variables are related to one another. Up arrow, and let's replace urban pop with assault. So we'll see, is there a relationship between the number of assault arrests, the number of murders? When you type enter, you see, there's a more or less diagonal line here. That means there is a correlation. This dot down close to the 0, mark shows that there are hardly any murders in a state that has hardly any assaults. And up here, in the top right, this state has a lot of murders and a lot of assaults. It's not perfect. Up here, the state with the highest number of murders doesn't have the highest number of assaults. Let's check another one. So up arrow, let's try assault and rape. And we see there's a clear relationship of crime, assault and rape, but it's not, again, a perfect correlation. Let's look at murder and rape. Up arrow again. And notice how easy it is to change what we're exploring. Murder in place of assault. Enter. Wow, that's an arc. So you can hypothesize maybe rape is a different nature of crime from murder. Now we have a tool that can be used to explore your data to see what trends, if any, are there. So to review, you used the mtcars database. The first thing you did was to look at the first 6 lines with the head command. Then using the structure and summary commands, you got a numerical picture, but the numbers are too hard to understand. So you loaded a package to give our graphics commands. You activated those commands with the library command, and then you used 3 plots to show the data in slightly different ways. Then you reviewed the same thing with the US arrest database, but the difference there was you defined a new variable to make it easier than typing US arrests with the capital letters, using the special RAssignment variable. So to reflect, R is a major data analysis tool that is suitable for kids from 8th grade up to begin learning. It's a real programming language, but it's not that hard to begin. And for what we can embrace, that AI and machine learning both can involve programming, but it's programming that we can do. It's not rocket science.